It's Mrs. Thompson. We are back in section 8.4 and we're going to discuss example 2. And what we're going to do is compare graphs. So we're going to compare two quadratic functions. And what we're going to compare about them are their widths, how wide they are. Remember, that's what we learned in example 1. And we're going to talk about and discuss their translation. Translation just means how much does it move up or down. Okay, so I've got a big hint right here for you guys. I'm going to underline it so it's very clear. You can underline it or highlight it or both. Basically, if your parent function is translated up, that means you're going to have a number, a constant number that's added to the back end of your x squared term. If it's translated up, that number will be positive. That's what C is greater than 0. Any number that's greater than 0 is a positive number, and so that means if C is a number bigger than 0, positive number, the graph will actually go up, okay? Now, if it's less than 0, if that constant number is less than 0, then the graph will actually move down the y-axis, okay? So I'm going to just do a real quick teaching off to the side before I get to example A here for under example 2. Let's say that we are graphing y equals x squared, and then we're going to compare that to y equals x squared plus 1. Okay? Now I'm going to change colors, but I want you to see what happens. Okay? This is the parent function that goes through the origin. Okay? I think you remember that. I hope you remember that. Let me change colors real quick. And this is the parent function moved up 1. And so now the graph's going to look like this. So that plus 1 right here just means we're going to translate up. The parent function is just going to move up 1 unit. Okay? So let me shift back colors here and let's talk about letter A and letter B together. So here's our parent function. Okay? And then here's the secondary function that we're going to compare the width of it as well as how it vertically translates. Does it move up? Does it move down? What's going on here? So let's start with the widths, okay? Now there's only two functions here, so we're just comparing the two. One's got to be wider than the other one. Now let me back up a page, and you can flip back in your notes to the very front page of our notes when we learned about widths of parabolas. Remember, and I'm right here, if absolute value of A is greater than 1, then the parabola is narrow. So the bigger the absolute value, the more narrow that thing is, okay? If A is less than 1, which that means it's either a decimal or a fraction, then the parabola is super wide. It's very, very, very wide, okay? So that's a little refresher. So we're comparing the width. So the absolute value of 1 is 1, and the absolute value of negative 1/3 is 1/3, okay? So remember, the bigger the number, the bigger the absolute value, the more narrow it is, okay? So we would say f of x equals x squared is more narrow than the g of x function, okay? And I don't have room to write all of that, okay? Or you could do the reverse. You could say g of x is wider than f of x, okay? Either way, I don't really care how you state it. You just need to know that the bigger absolute value means more narrow, and the smaller the absolute value, if it's a fraction or a decimal, then that means it's wider, okay? So either one of those statements. You don't have to have both. You just need to have one that you're comparing, okay? Now the other thing we want to look at, we want to describe how it's translated. So we're going to start with the parent function here. We know that it goes through the origin, okay? Just like I showed you over here on this side right here. And what we want to do is we want to look and see, well, if we were to graph g of x, which is equal to negative 1/3 x squared plus 2, if we were to graph that, how would it vertically translate? Well, you would have to look at that constant number plus 2. Remember what I said at the beginning of the video. If c, which is your constant number, if that's a positive number, the graph is going to move up, okay? And if it's less than 0, if it's a negative number, it's going to travel down the y that many units. So we have a plus 2. So what that tells us is that g of x vertically translates two units up. Okay? And that's how you would describe a vertical translation. There's actually a third thing we could compare, and that is whether the graph opens up or down. And we know f of x opens up while g of x opens down. But I think the nature of this particular problem is that they specifically wanted you to compare the width of the two parabolas as well as the translations, the vertical translations, okay? How it moves up or down. And of course, C dominates that. You look at C, and that'll tell you how much it does, okay? So let's take a look at letter B, and let's start with the width. So we've got width, and here's f of x, and we've got, well, it's got a 1, absolute value of 1 is 1, and g of x is absolute value of 2, which is 2. So it doesn't matter how you word it. You can say f of x is wider than g of x, or g of x is more narrow than f of x, okay? So just pick one of those. The smaller number is wider, the bigger number is more narrow. So f of x is wider than g of x, okay? Excellent. Now, the next thing we want to do is we're going to talk about the vertical translation, okay? Now, I put vertically translation, vertical translation, excusez-moi. What you want to do is you want to compare the c's. So in the f of x equation, just to be even more clear than I hopefully was before, in the parent function, 0 is your constant number, because there is no constant number, it's an understood 0. And then g of x has a constant of -3. So what will happen to the g of x? G of x is more narrow, and it also will translate down 3 units, okay? So g of x translates down 3 units, okay? And that's how you compare width and vertical translation. Width, you already knew how to do that. That's example 1, okay? So we're just layering on top of example 1 with example 2. We're just adding the concept of vertical translation. That's all we're doing. Now let me take a sneak peek at our next page. Yes, I left you with some here to do. Let me do C with you real quick, just because that's an interesting situation. And then how about I'll make a deal with you. I'll give you D and E as extra credit. I know how much you guys like your extra credit. Okay, so let's compare the widths, okay? So for f of x, the absolute value of 1 is 1. And for g of x, the absolute value of -1 is also 1. Well, what do we say when they have the exact same absolute value? Well, we would say they both have the same width. So width is not determined by positive or negative. That's why we take the absolute value, because that has no bearing. The width is determined by the absolute value of A. That's really what's going on here. Okay, let's look at the vertical translation. So vertical translation, you look at the parent function, it's starting at 0 on the y-axis, and The g of x says to bump it down 4 units. So that's what's going to happen with g of x, is it's going to have to go down 4 units. That's how it's going to move away from the f of x. Now, I hope I was really super clear. If not, we will talk about this a little bit more in class tomorrow, and if I need to actually graph these for you, I will. I was kind of hoping I didn't have to graph them. Okay, so let me leave D with you and E. That is for you. And I'm looking for 2 pieces of information. I want to know, tell me something about the width, compare the widths of these 2 functions, and their translation. How does g of x translate compared to f of x, okay? So give it your best shot and bring your questions to class tomorrow.